Good morning, Geometry Honors students. So it's Mr. Chen again. So today I would like to talk about sections 10.6. It's about the all the segments theorems in circle. So it's in general it's called the power theorem. Objective: apply chord-chord, secant-tangent, and secant-secant theorem. So we do have three different types of power theorems. So the first one is called a chord-chord product. So the chord-chord product, as you can see that here, it's like AE times DE. So that equals BE times CE. Another way you can say that this one AD is just a chord. Okay, so chord 1. So let's label this one as chord 1. And then BE, then that'll be chord 2. So AE, as you can see that here, so AE, that would be standing as the major segment of chord 1. And then the other one, it's the minor segments of chord 1. So you can say that this one is the major segment of chord 1 times the minor segment of chord 1. So that equals the product of the major segments of chord 2 times the minor segments of chord 2. Okay, so that's another way you can label it. So what about for the tangent secant product? So as you can see that here, so DC, that's considered the tangent segment, and then AD, so that would be the secant segment. So the way to find out about this, so this one is about the product of AD, the secant segment, times BD, the external segment. So that equals CD square, which is the tangent square. Okay. So another way to name it, this one is called the secant segment times BD, which is the external segment, along that secant, and then so that equals CD tangent square. Okay, again, chord-chord product, so this one can say that's the major segment of chord 1 times the minor segment of chord 1. So that equals the major segment of chord 2 times the minor segment of chord 2. Secant-secant product, so that's another power theorem. So this one, it's AE times DE, so that equals BE times CE. So this one you can say that the secant 1, external 1, secant 2, external 2. Okay, let me just unplug that power cord. So AE, so which is what? The secant 1. DE, which is external 1. BE, secant 2. And then CE right here, external 2. Okay, so using that, the power theorem, to find out the missing variable. So this one here, so as you can see that it's a secant-secant product. So let's find out that secant 1. So secant 1 would be 5 plus x. External segment, it's x. So secant 2, 6 plus 8, which is 14. And then external 2, so that would be 6. So multiplied it out, so we got 5x plus x squared, and then 6 plus 8, that's 14. 14 times 6, 84. And then solve for x, bring everything together to one side. Okay. And it looks like this one, it's not factorable. So we do know that 14 times 6, that's 84. Okay, so try something else. Divided by 4. So the thing is that if that's not factorable, so you want to use the quadratic formula to solve for this. So negative 5 plus minus square root of 25 minus b squared minus 4ac. So 4 times 1 times negative 84. All over 2a. So it's negative 5 plus minus, so 25 plus Okay, 84 times 4, 16, 32, 336, all over 2a. So this one is negative 5 plus minus 361. Okay, so which is, it's a non-perfect square number. Well, actually it is. 361, that's 19. Square root of 361, it's 19. So this one is written as negative 5 plus minus 19 all over 2. Cannot be negative, so it's only positive, so plus 19 divided by 2. So this one turns out to be 14 over 7, which is 14 over 2, which is 7. So x would be 7. So we try to factor this out, so probably divided by 7. So once you divide it by 7, you'll get, yeah, so it would be factorable, 12 and 7. So instead of using the quadratic formula, so this one can be written as x minus 7. And then, let's see, divided by 7, 12. So x equals 7. Okay, so now let's see what else that we have for this. So here's another one. So this one is the external. Okay, it's a tangent with a secant. So using that, the formula. So tangent square. So that equals secant times the external. So tangent square, so y square equals secant. So a plus 6, 14. And then external, so times. Well, let's just show the whole process. So this one, it's secant a plus 6 times the external, so times 6. So y squared equals 14 times 6. 84. Again, square root. So y equals, well, it's going to be positive because that's the line segment. So this one divided by 4, top and the bottom, so we got 21. Okay, so 2 root 21. Okay, now the next one, so it looks like this one is a chord-chord product. So again, major segment times the minor segment of chord 1, so that equals the product of the major segments of chord 2 times the minor segments of chord 2. So 2z minus 1 times 4, so that equals z plus 7 times z minus 2. Multiplied it out, so 8z minus 4, so that equals z squared. 7z minus 2z, 5z, and then negative 14. Bring everything together, so 0 equals z squared. 5z minus 8z, negative 3z. Negative 14 plus 4, negative 10. And is this factorable? It should be factorable, so this one z minus 5, and then z plus 2, so z equals 5. Can z be negative 2? Cannot be negative because that's the line segments, so just z equals 5. So z equals negative 2, then that'll be the extraneous solution. Okay, so make sure that you guys recognize all those formulas. Again, the secant-secant product, the secant external equals that tangent square, and then the chord-chord product. Okay, so all those main formulas that you need to recognize for this section here. Okay, so thank you for watching the video today, so I'll see you next time. Take care.